In the world of database history, some systems just store data, but others fundamentally change how we think about identity itself. Today, we're doing a deep dive into the architecture of one of those systems, the FBI's Next Generation Identification System, or NGI. This is the story of a database that truly changed the face of law enforcement.
To really get a feel for its power, we have to start with a case that changed everything. Picture this. It's 2014. Police are looking for a suspect, but the key piece of evidence isn't a nice, clean fingerprint. No, it's something way, way trickier. A street camera grabs a grainy, low-resolution picture of a person's face. That image gets fed into the system. And here's the magic. In seconds, the system breaks that face down into a totally unique mathematical signature, what we call a vector. Instantly, that vector is blasted against a database of millions of faces, and bam, a match. This wasn't some sci-fi movie. This was NGI in action, showing the world that identification was no longer just about fingerprints. Now, a system this powerful doesn't just appear out of thin air. To really appreciate what a massive leap forward NGI was, you have to look at the system it replaced. Its predecessor, IAFIS, was an absolute legend in its day. But by the late 2000s, it was really starting to show its age. It was hitting a wall, and fast. I mean, the difference between what they had and what they needed was just night and day. IAFIS was a one-trick pony. It did fingerprints, and that was about it. It choked on high-resolution images, and trying to match a smudged print from a crime scene could take hours. Modern law enforcement needed something completely different. They needed a system that could handle everything: faces, palm prints, even iris scans, and give them answers in seconds right on their devices in the field. So what do? Well, in 2008, the FBI started one of the most ambitious engineering projects it had ever undertaken, to build a true biometric super system from the ground up. The vision was to create one single unified platform that could handle any kind of biometric you could throw at it, and do it at a massive scale.
And this is what they came up with. NGI wasn't just a simple upgrade, it was a total architectural rethink. Suddenly you had fingerprints, palm prints, facial recognition, and iris scans all living under one roof. But it went even further, adding brand new capabilities like RAPBAC for continuous criminal monitoring and Rapid ID for mobile devices. This is what engineers mean when they talk about a multimodal system. It speaks all the different languages of biometrics.
Okay, so how does it all work under the hood? Let's follow the data. First, you capture the biometric, a photo, a scan, whatever. Then, really sophisticated algorithms go to work, almost like a digital artist, pulling out only the most unique features. You know, the tiny swirls in a fingerprint or the specific patterns in an iris. And here's the most important part. Those features get converted into a mathematical vector. You can think of it like turning a face into a unique, super long barcode. That string of numbers is what gets searched, which is what makes it all so incredibly fast. And this is where that search actually happens. The brain of NGI lives inside the FBI's CJIS data centers. And let me tell you, these are not your average server farms. These are digital fortresses. We're talking hardened buildings with backup power, backup cooling, backup everything, all designed for zero downtime. The engine is this beautiful symphony of distributed computers and parallel processing, all humming away across petabytes of storage. So when you combine all that brilliant engineering, both the hardware and the software, what do you get? You get a leap in performance that is just staggering. It's honestly hard to overstate the scale and the speed of this thing. Let's just try to wrap our heads around the numbers. The system handles over 200 million fingerprint transactions every single year. That works out to more than 500,000 checks every single day. That's just the normal, everyday traffic. And every one of those searches is running against a core database of over 100 million individual fingerprint records. That's a population larger than most countries on Earth. And that's not even counting the tens of millions of palm prints and facial photos. The sheer volume of data is just wild. But it's the speed that really tells the story. A search for a latent print from a crime scene, that took hours on the old system. On NGI, it takes minutes. A facial recognition search, we're talking seconds. This wasn't just a small improvement, it completely changed the pace of investigations. It wasn't just about doing the old stuff faster. NGI introduced completely new tools. Palm print matching, for example, was a total game changer, since palms get left at crime scenes all the time. Iris recognition added a new layer of security for high-risk situations. RAPBAC created this continuous alert system for people in trusted jobs. And RISC, Well, RISC basically put the power of that entire massive database right into an officer's hand, giving them results in under 10 seconds.
But here's something really important to understand. NGI's true power isn't just what it can do on its own. It was built from day one to be the biometric heart of a much bigger, interconnected web of data systems. So NGI definitively answers the question, who is this person? It does that by plugging directly into the FBI's other core systems. It talks to NCIC to get criminal history. It feeds identifiers into Index to help connect the dots between people, places, and events. And it supports Sentinel, the FBI's main case management platform. When you put them all together, they form this deeply integrated data backbone for federal law enforcement. But as we all know, technology never, ever stands still. And even a system as revolutionary as NGI, built just over a decade ago, is now starting to bump up against the limits of its architecture. Why? Because it was built in a pre-AI world.
And that's really the key takeaway here. NGI was a masterpiece of its time, but it wasn't designed for a world where we need to analyze real-time video streams or run massive AI models. Its entire architecture came before the explosion of things like specialized vector databases and the kind of advanced machine learning that can blend all sorts of different data together. The next step is going to require a totally new approach. Which, of course, leaves us with a really critical question for the future of database design. As all this data, biometric and otherwise, gets infinitely more complex, how do we engineer systems that don't just find one little data point, but can actually see the whole picture? Well, we're going to dig into the answers in the next part of our database history series. We're going to explore the modern FBI tech stack, the CJIS cloud, the incredible rise of vector databases, and the AI-powered systems that are writing the next chapter of identification. You're not going to want to miss it. Thanks for joining us.